Welcome to today's webcast, Network Traffic Analysis, Improving Your First Line of Defense, presented by Corelight and ESG. Quickly, the agenda, and then I'll introduce today's panelists. We will look through ESG survey results and NTA requirements presented by Jon Oltsik. I will walk through NTA security challenges that customers may face as they evaluate solutions and approaches in the market. And lastly, I'll illuminate Corelight's NTA capabilities and how they can drive great customer outcomes. And we'll close on Q&A. We're joined today by an esteemed security analyst in the space, Jon Oltsik. Jon, if you want to introduce yourself and talk a little bit about your background.
Sure, thanks, John. So I'm Jon Oltsik, Senior Principal Analyst and Fellow at ESG. I cover all things cybersecurity, but focus on security analytics and operations, and that includes network security and network traffic analysis. So I'm happy to be here, and I'll be presenting and answering questions as we proceed.
We're so glad you could join us, Jon. And I'm also a Jon with an H, and I'm the Director of Product Marketing here at Corelight. I've been in the data protection space my entire career, going on 10 years now, and worked across a variety of different identity verification, security technology, privacy technology products, and I've been here at Corelight representing our network traffic analysis sensors for just about 2 years now. So Jon, I'm going to turn it back over to you to present some of your survey results and how you guys look at the NTA space and framing requirements for customers.
Great, thank you.
And just let me know for next slide, you can just say next.
Okay. So again, Jon Oltsik here. I'm going to talk about threat detection and response and network traffic analysis. I'll be using some recent ESG data to exemplify my points. Now, NTA is not just for threat detection and response alone. It's an anchor product for security operations centers. It's often used for monitoring and understanding how the network is behaving, what's on the network. But in this case, I'll really focus my attention on threat detection and response. So if you go to the next slide, I'll look at threat detection and response realities. Once again, using the ESG data as background. And this will tee up the use case for network traffic analysis, or NTA. So how it's used today, and then what organizations need in an NTA platform. So we have good data on that. And then I'll also mention some future plans that we saw from our research. So you can go on to the next slide, please. So I like to level set whenever I look at a topic in cybersecurity with a point in time evaluation. So how are things today in relation to how they were in the past? And with respect to threat detection and response, the data suggests that 76% of organizations surveyed say that threat detection and response is more difficult today than it was 2 years ago. Now, this is a very common pattern with security, that things are getting more and more difficult over time. And think about what other professions you can say that of. So what other people that you know that you see at cocktail parties or around at school functions or what have you, are working in an environment that continues to grow more difficult all the time. Well, that's the reality of being a cybersecurity professional. So if you can click and build this out. So I should also mention that 45% of those we surveyed said that threat detection and response is much more difficult today than it was 2 years ago. And that group is dominated by larger organizations with more security resources. Well, why is that? Why are things getting more difficult? So we asked that 76% of the total survey population will tell us why that's the case. And you see that data on the right hand of your screen. So the number one response was that the volume and sophistication of threats has increased. So any threat detection and response solution must be able to deal with volumetric threats, but also sophisticated threats that may have multiple phases to them. So we think of APTs or kill chains. We have to be able to deal with that in our detection and our response methodologies. 17% said the threat detection and response workload has increased. So we've got the same number of people doing way more work. That does not work in any profession. It doesn't scale. And one of the things that I do research on all the time is on the cybersecurity, the global cybersecurity skills shortage, which is getting worse. So we've got not enough people, they may not have the right skills, and we're giving them more work to do. That doesn't work also. And then the attack surface has grown. What does that mean? It means we have more network traffic, more devices connected to our network. Some of those devices are new and unusual, like IoT devices. We have more workloads moving to the cloud, so we have cloud infrastructure. So we're asking the same number of people to monitor our network security while the volumes and sophistications of attacks has increased and the workload has grown. That just doesn't work. It won't work in any context, so people need help. If you go on to the next slide, we also asked about challenges. And there's a long list of challenges here. I certainly don't have time to go into all of them. I'm sure that Corelight will make these slides available, so please take a look because it's good data. There is sort of a laundry list effect here where there are a lot of challenges, but I'll talk about a few. So at the top of the list, 36% said that the cybersecurity team at my organization spends most of its time addressing high priority or emergency issues and not enough time on strategy and process improvement. So we're in constant firefighting mode. And this means we're prone to human error. It means that our few skilled SOC analysts are being asked to do superhuman tasks and they're getting burnt out. And as the response suggests, there's no process improvement. So we're doing the same thing all the time. We're on the same treadmill all the time, and we're not making improvements or strides. How is that going to work when the threat landscape is getting more sophisticated and there are more targeted threats? It doesn't work. 30% said my organization has added new hosts, applications, and/or users. So this is, again, the attack surface increasing. So we need solutions, and in this case, NTA solutions, that have visibility over the entire network, that can understand when new hosts come on board, that understand the traffic patterns between hosts and between users and hosts, and then can make the right determinations for accurate detection. 30% said there's one or several blind spots on our networks. In this case, it says due to the inability to deploy agents, but let's ignore that. Let's just talk about blind spots in general. You can't manage what you can't measure. In this case, you can't monitor security when you can't see what's happening on the network. So we need ubiquitous network visibility. And 26% say my organization's threat detection and response processes are anchored by manual processes that hinder our ability to keep up. Well, we've talked about the skills shortage. Manual processes add to that. So what can we automate, and how can we make the lives of those security analysts easier? That's one of the determining factors in choosing any solution, and in this case, an NTA solution. So as we look for solutions, what should we think about? Well, as we go on to the next slide, this is something I say commonly. It's something a lot of security professionals say. When you think about threat detection and response or cybersecurity activity in general, the network doesn't lie, meaning that the network is almost always, and I would say always, a part of some type of cyber campaign, cybersecurity campaign, or cyber attack. So think of kill chains. Kill chains have multiple phases, but some of those phases really are dependent upon the network. So things like lateral movement across the network from an exploited or compromised system to find other things, other resources on the network. Privilege escalation. So I find that Active Directory server, or I find that valuable data, and I want to get administrator rights to that. Well, chances are I'm conducting that from one system to another, or I'm going in through a back door and going across the network. The network will see, if you're looking for it, if you know what to look for, you'll see that type of activity. And finally, data exfiltration. So I've got to move valuable data from your network to my network. Well, there are all kinds of ways to uncover that. And you can do that at the network layer based on flow data, based on connection data, based on protocol data. So if you know what to look for, the network doesn't lie, and therefore there's interest in NTA products. If we go on to the next slide, our research says that a majority of organizations already use network traffic analysis to some extent. So you can see, in fact, 61% said that NTA is in extensive use in their organization already, and 26% say limited use, and then others are in the process of adopting NTA. Well, this shouldn't come as a surprise. It didn't come as a surprise to me. We've seen in the past security analysts using open source tools, things like TCP dump and Wireshark. We've seen them use basic PCAP tools that were good if you knew what to look for and had an abundant amount of time to look for it. We've seen them use net flow analysis, which is good for a high-level view of what's happening in the network, but not really a deep dive. But the point here is that NTA is familiar to security analysts. They have, a lot of them come from the networking world. So the thought is, well, if security analysts are comfortable with NTA, let's give them the best NTA solutions that they can use that make their jobs easier and make threat detection and response more accurate, more efficient, and more effective. And that's what we're after as we proceed. Now, if you go on to the next slide, NTA is one of many products that I would use for threat detection and response. So the question here is sort of, where does it fit in the hierarchy of tools that I would use? Well, in this case, we compared NTA to EDR. And EDR has certainly made a big, or had a big presence in the market over the past few years. But given that pedigree with network security, it didn't surprise me that 43% of those we surveyed said that their organization uses NTA as a first line of defense for threat detection, as compared to 23% who use EDR, or 29% who say they use NTA and EDR together. So what does a first line of defense mean? It means that I have got eyes on glass on an NTA solution. I'm looking for anomalous behavior. I'm investigating things that people have told me, maybe about to monitor an insider that may be conducting malicious activity, or maybe malicious connections, or an internal botnet or something like that. So NTA is my first line of defense. But what I'll do is I'll pivot from NTA elsewhere, depending on what other tools I have, to get more data and more information on that proceeds in the sequence of an investigation. So NTA is a really, really important first step. And then, depending on what my NTA can do, I may supplement that tool with other things in the network. So if we go on to the next slide. What are the key attributes of network traffic analysis? So once again, there's a list of things. I'm not going to go through them all, but I'll give you some color of what people want in an NTA solution. Remember, they've probably been using NTA-like products for years, so now they're looking at commercial solutions. They're looking at open source solutions. They want the most they can get, and this is what they want. So 44% say built-in analytics to help analysts detect suspicious and malicious endpoint behavior. So that could be network behavior as well. So they want dashboards, they want heuristics, they want algorithms, they want visibility across all the network protocols. They want wide support, and they want a growing user community around a particular NTA so that they can go out to their friends when they go out to network or security associations and security events and get tips and understand more about how to use a product. 44% want threat intelligence services integration built into NTA. So the thought there is I've got good analysis with an NTA about maybe suspicious or malicious behavior inside my network. Well, how does that relate to what's going on in the wild? Are there any indicators that I can then correlate to known attacks or known cyber adversaries, known adversary groups? So think about integration with threat intelligence, but also integration with the MITRE ATT&CK framework. So I can put an attack in context with, or an event in context with an overall attack pattern. The ability to monitor IoT traffic, this is relatively new, a relatively new requirement. It's a growing requirement, and it's especially important for certain industries: manufacturing, healthcare, transportation. We're seeing a lot more interest there. And then the ability to monitor all connected network nodes and issue alerts when new network nodes are connected. So we're seeing, if you go back to network access control or NAC, we're seeing some overlap there, at least to understand the behavior of any kind of new device on the network and understand it in the context of what it should be doing, maybe what it's doing anomalously, or what it's doing in relation to some kind of known attack. So NTA is a first line of defense, and as I mentioned, we're seeing organizations pivot from NTA elsewhere. So this leads me to my next slide. This is an architectural stack diagram of what we think the world is evolving to for security operations and analytics. We call it SOAPA, or Security Operations and Analytics Platform Architecture. Now, there are a lot of words on this paper, or on this slide, so I can't certainly go into all the detail. But if you go from the bottom up, it starts with security telemetry. We need to collect, process, and analyze that security telemetry in an efficient way. So we want to collect it in some kind of common repository with common data services. We want that data to be available to any analytics tool that wants it, so sort of a publish and subscribe or a message bus. We want an analytics layer, so that could be different types of analytics tools, in this case NTA. And then that NTA should be able to integrate with a security operations layer so that we can take that data and then act upon it, and act upon it with automation or orchestration across a variety of tools. So this is our architecture. NTA fits into this, and in this case, NTA would be one of the components in a SOAPA architecture. So if you go to the next slide, threat detection and response is a business critical problem. This isn't a security problem. This is a business critical problem. We see lots of organizations buying cyber insurance for this reason, because they're not doing a good job of detecting and responding to attacks, and so they need to cover their losses. But another thing that they will do is increase their internal spending on threat detection and response products and services, including and highlighting NTA. So 47% will increase spending significantly, and 42% will increase spending somewhat. And as you can see, only 12% either won't increase spending or don't know. So if you go on to the next slide. So these are some of the things that, some of the strategic initiatives people have to improve threat detection and response over the next 12 to 18 months. So 30% will actively develop or build, build or purchase an integrated software architecture for security operations. So this is referring to my SOAPA architecture or something similar, and NTA will be a part of that. The reason to do that integration is to, again, it's the force multiplier effect. One tool supports another tool, supports another tool, adds to the efficacy of your security infrastructure. 30% want to improve the alignment of security operations and IT operations processes. So in this case with NTA, you need a common set of data or common data repository. You need common tools and dashboards that can be understood by security and network operations teams. Purchase security operations tools designed to help organizations automate and orchestrate security operations processes. This is really to improve efficiency. Again, we're overwhelmed by the amount of tasks. We need the technology itself to help with some of the heavy lifting. So if we go on to my last slide, the bigger truth is my summary and conclusion. So Einstein's quote applies here. Now there's some debate as to whether Einstein actually said this, but I'm referring to the quote of the definition of insanity is doing the same thing over and over again and expecting different results. We can't continue to patch network security. We can't continue to just add things, add tactical tools incrementally. We need more strategic solutions. We need better solutions that can improve the efficacy and efficiency of security. And NTA is a good place to start. New NTA tools like Corelight can produce high fidelity analytics and alerts, so we can improve our threat detection, lower false positives, and get to response and remediation much quicker. So there's a strong time to value and a strong ROI. And I should add that CISOs have a finite amount of resources, so they have to pick high value, quick win solutions. And in my mind, NTA is absolutely that, especially this latest generation of NTA tools. And towards SOAPA integration, so network traffic analysis has to fit in with SIM. It has to fit in with EDR. It has to fit in with threat intelligence platforms and SOAR. So as you look at solutions, make sure you choose those that have ecosystem partners, vendors with ecosystem partners that are built around APIs and built around open source and built around communities, because the goal is, again, force multipliers. How do I buy a new solution that makes everything else I do, including my people and my processes, better, faster, more effective? So with that, thank you very much for listening today. I'll stick around for Q&A. Let me turn it back over to my friend, John Gamble.
Thank you very much, John. I think you did a great job kind of quantifying the market space today and explaining, why customers are turning towards NTA increasingly and what those security challenges are, the staffing challenge, the putting high priority people in constant reactive mode to go after these alerts and these network visibility gaps that they can't close. And so I think that's just a great transition into this next section where I'm going to dig a little bit into some of the technical security challenges that kind of underpin this space when customers are trying to analyze their network traffic. And then lastly, we'll kind of close on what Corelight's capabilities are before rolling over to the Q&A. So this is kind of the problem that we're dealing with as an industry, right? Is that the dwell time of cyber attacks are measured in months, not minutes, right? People breach networks, they get inside of an organization and they're able to laterally move undiscovered for weeks upon weeks. And the average attack goes undiscovered for almost 3 months, 78 days. And this comes from the FireEye's 2019 M-Trends report. And that's what we're all here to address and what we're here to reduce. We cannot allow attackers to go undiscovered inside of an environment for almost 3 months. So what's happening behind the scene? John's survey results showed some of the kind of organizational challenges that customers are facing. But if we break that down into kind of key conceptual problems within the SOC, what are we looking at? Well, there's a couple ways to tackle this challenge, right? There's detection. The challenge there is, of course, there's no silver bullet, as we all know. Machine learning, AI is not a perfect technology, and it's getting better with time, but of course, there's no silver bullet out there in the market. So at best, you're going to be catching part of that step across your environment as they're making their way over those 3 months. You're not going to catch the full thing. And those tools are still creating a lot of false positives, which means there's a lot of noise. And that analysts, human analysts, have to look at this kind of opinion generator and figure out what's the wheat for the chaff. And that's really challenging. From an incident response perspective, there's this hiring talent crunch that the security industry is under, which is that there's not enough people out there to do the jobs that need to be done in the SOC. And consequently, these incident responders are just absolutely overwhelmed, and they're constantly in firefighting mode, and they're constantly trying to get through a backlog of events and alerts that grows ever longer because they can't keep pace with the scale of alerts being generated. And so they're missing those true positives in this process. And lastly, from a proactive human analyst-driven threat hunting perspective, one of the challenges there is, of course, visibility. As John mentioned in those survey results, a lot of organizations out there are saying they can't get visibility into certain parts of their network. They're flying in the dark when it comes to certain areas of network traffic because they don't have the ability to see it. And that means the threat hunters themselves are hampered and they can't go out and inform hypotheses and proactively look for evidence of risk on the network. So, the question is, what do these three things share in common when it comes to data and network traffic analysis? Well, we here like to say that the network data that most security analysts are using today, it wasn't built for security. It was designed for IT. Security grabs this data to analyze their network traffic because it's what's available, not because it was purpose-built for their needs. And so you get a bunch of logs, your firewalls generating logs, your SMTP servers are generating logs, your routers are generating net flow, and you're basically playing this bad puzzle game on the right as a security analyst who's trying to make sense of what's happening on the wire of reassembling these puzzle pieces. And the problem is, of course, they're not interconnected. The format often differs, and there's gaping visibility gaps in between these data sets. That's if you can even aggregate them all in one data lake or SIM tool. And of course, those logs at the end of the day were built for performance management and troubleshooting. They were built for IT to basically troubleshoot the health and performance of these network devices, not for security. And so those have important implications because it's things like your typical DNS server record, for example. It doesn't contain the DNS response to a DNS query. Well, that's not necessarily critical for an IT perspective. From a security perspective, you need to see that response because that could be a C2 communicating back into the network via DNS tunneling. But of course, the DNS server record by default wasn't designed for security, so it doesn't include that information. And then lastly, of course, there's PCAP, right? You can try to capture all the packets on your network and analyze them at scale, but that very quickly outpaces the storage capacity and human analyst insight abilities of most organizations to move quickly. And so you're historically limited in your visibility, and the human analyst is going to spend hours in a tool like Wireshark tearing those pockets apart just to get to a single security insight. And so the SOC today, when it comes to network traffic analysis and the data that underpins that analysis, find themselves between a rock and a hard place. They're trapped between not enough data with these network IT logs like NetFlow and just too much data trying to drink from the fire hose of full packet capture. And as I mentioned, the challenges there are, of course, on the IT log side, difficult to aggregate and correlate, and massive visibility gaps that lay in between these logs. And on the right, it's time to insight, very slow compared to some of those lighter IT logs, and your historical visibility is limited. So when a dwell time on average is measured in almost 3 months, and you need to go back in time on your network 2 months, packet capture is not going to help you because no organization is storing packets for more than a few hours, days, or weeks at most. And so you're flying blind to historical traffic on your network beyond that time window. So where does Corelight fit into this? Well, in between that rock and a hard place, you can kind of think of us like the Goldilocks of network data. We provide just the right amount of data about the network in just the right format, at just the right size, purpose-built for security. And what that literally means is we take raw network traffic and we transform it into 3 key outputs. 1, protocol comprehensive logs that allow security analysts and security analytics to track attacker behavior across the network, across ports and protocols. 2, we take that raw traffic and we actually extract and reassemble the files crossing the wire, the PowerPoints, the PDFs, the executables, which of course from a security perspective are immensely important to analyze since file-based threats are often a common vector for deploying malware into your environment. And lastly, we enable custom insights, custom behavioral analyses and analytics to be built on top of this rich data set. And that's due to the fact that we're actually based on an open source technology called Zeek, formerly called Bro, and it allows users to script custom detection and monitoring tasks on top of this rich data set. And so real quickly about Corelight, we were actually founded by Zeek's inventor, Dr. Vern Paxson, and its core open source developers. And we're headquartered here in San Francisco, and we're a rapidly growing Series B company with 100+ employees, and we've got a presence in the Americas and EMEA as well. And I'm going to dig more into these technical capabilities in these next few slides. Just to talk a little bit about Zeek. So again, our Corelight's product offering is built on top of this open source technology called Zeek. Zeek has been around for decades. It was actually first invented in the 90s over at Lawrence Berkeley National Lab by Dr. Vern Paxson, one of Corelight's co-founders, as I mentioned, because he was trying to analyze high performance network back in the 90s that didn't really exist in the corporate environment at that time. And so he was encountering network traffic analysis problems that most companies wouldn't encounter for another decade or two. And it's this continually living, breathing, adaptive code base, of course. It's open source. So there's people contributing to it all over the world. They're writing new protocol parsers. Actually, just last week, a group of developers over at Salesforce wrote and released an open source protocol parser for Zeek that looks at a new Google protocol. So it's this living, breathing, adaptive code base that's always ensuring that its network traffic analysis capabilities are keeping pace with the customer needs and the market needs. Now, there's also crowdsourced insight that can come from this data, right? So you've got people writing these scripts and releasing them and sharing them with the community. And these scripts can do things like look for evidence of cryptocurrency activity in your network traffic, or they can look for port scanning behavior on your network. MITRE, so Jon mentioned the MITRE attack framework, which is a hugely important framework increasingly in SOCs around the globe to map and reduce risk in the organization. The MITRE organization itself actually wrote and released a set of Zeek scripts called the BZAR scripts. And they look for evidence of lateral movement in your environment by analyzing SMB traffic and DCE traffic in your environment, looking for telltale signs of lateral movement. So it's a detection-oriented Zeek script. You know, of course, as an open source project, you have a community to draw on. It's a network evidence standard for network traffic analysis. You know, it's taught by the SANS Training Institute's courses. It's part of Cisco's CCNA certification. It's accepted as a network evidence format by all major security tools out there. You really can't find a major SIM that doesn't accept Zeek logs. There's thousands of security analysts out there that are Zeek ready and trained and knowledgeable. And you know, it's an industry standard that allows you as an organization to scale and build the best of breed network traffic analysis infrastructure in your environment. You can plug and play tools at whim because they all pretty much accept Zeek. And you know, we at Corelight, of course, are biased, and we love Zeek. But again, this is a global community movement that's been around for 2 decades, and these are just a small selection of companies that have publicly acknowledged their reliance on open source Zeek for network traffic analysis. And as you can see, these are some pretty substantial organizations. You know, Zeek was born out of the Lawrence Berkeley National Lab environment, and for the first couple years of its life was really a tool used by high-end government organizations, you know, national security focused agencies globally, higher, you know, learning R1 research universities, national laboratories. And it's really only in the last 10 years that it's spread organically into the enterprise environment. And as you can see, it's trusted by some of the world's leading security teams at some of the world's biggest companies. So Corelight, we sit as the anchor tenant of your NTA stack. You know, we're not offering a pane of glass or kind of a broad security analytics package out of the box. We take that raw network traffic that's mirrored to our sensors, and we transform it into those 3 key outputs. And then we stream it downstream to a security tool of your choice, an analytics tool of your choice. Really, the sky's the limit in terms of what you can send our data to. And so we work with your environment. And lastly, of course, the orchestration and automation layer that Jon mentioned in his diagram. That's kind of the top of the network traffic analysis stack. The ability to have this beautiful closed circle where a packet is captured, it's sent to Corelight, transformed into usable, actionable security data, sent downstream to a security analytics pipeline and lake, and the fidelity of that signal generated out of that is so high that the analyst is comfortable letting an automated response kick in. That's kind of the dream. That's how we automate and scale our way out of some of these problems that the industry is encountering. We offer a range of Zeek-based network sensors in physical format, in cloud format, and in virtual format. So we can meet, you know, your network needs, whether that's a hybrid network, a cloud network, an on-premise network. We offer physical appliances for varying physical network throughput speeds, 2, 10, and 25 gigabit per second appliance models. We offer on the cloud side, we offer an Amazon sensor is our first cloud product in market today. And the virtual side, we can support VMware and Hyper-V environments as well. And we also offer fleet management capabilities, so you can configure, tune, and deploy these sensors at scale across your organization. Now, I'll spend a minute on this because this is a pretty important diagram. It really illustrates where Corelight can fit into the network traffic analysis stack and your environment. And as you see here, if you look across this kind of logo splash of other companies, you can see that we fit into your existing stack. We're not disruptive. We're not here to replace a huge piece of infrastructure in your environment. We're an additive layer that makes all of your tools and all of your processes better and more efficient in your security operations center. And so from an ingestion side, we're dependent on our upstream partners to actually mirror that traffic. So in a physical networked environment, those are packet brokers like Arista, cPacket, or Garland Technologies. In the public cloud environment, from the Amazon perspective, we can take traffic from their native VPC traffic mirror, or we can also take mirrored traffic from cloud-based packet partners, packet mirroring partners, I should say, like Nuveva. So our sensors there take those mirrored packets, and the customer can actually overlay their own data set against those incoming packets, so they can enrich the data set with their own internal whitelist or blacklist or organizational info, so they can actually start to identify servers or include contact information for relevant response teams. So that data gets pre-enriched, and they can also overlay threat intelligence before sending it downstream to their data lake tool or their SIM. So they can actually pre-process the Corelight logs with tools like Anomaly or ET Intelligence, where they're looking for IOCs in those logs. And if they're getting a hit, a separate log called a notice log gets generated and sent downstream to a tool like Splunk. And of course, on the right side of the diagram there, you can see the whole ecosystem, actually a sampling rather of the ecosystem of partners that Corelight can work with. We support all major SIMs. We've done a lot of engineering work to directly integrate to make that downstream streaming process very simple to set up, just a matter of minutes to get your data out of Corelight sensors and hooked up to your tool of choice downstream. And of course, on the file analysis side, because we can extract and reassemble those files, we can also send those files downstream to a tool like FireEye or Cuckoo to actually do file-based analysis. Now, to dig into this data a little bit, what makes this data Goldilocks data? Not too much, not too little, just the right format, optimized for security use cases. Well, here's just a sampling of some of more than 50 different log types generated that cover more than 35 major network protocols and encompass more than 400 different fields of data extracted. And if we kind of look at these really quickly here, so what makes this data special? Well, a couple things. It's because it's built for security teams, every single field in these logs has security value. There's not a single line in any of these logs that got added just because someone thought it would be neat or because someone else not in security thought it could be useful. Every single field in every single log is for security, and it wouldn't be there otherwise. And also, these logs are interlinked, which is an incredibly important concept in the security world, because with interlinked data, security analysts and tools can make lightning fast sense of what's happening on the network. And speed matters in security, right? We can't allow these attackers to be dwelling for months undetected, despite numerous network-based communications and opportunities to catch them. And so with interlinked data, you can actually move much faster across your network from an analysis perspective. And so what you see here in this diagram are some of the correlation fields that Corelight and Zeek put into these logs. And so there's a timestamp, there's files that get automatically hashed, and perhaps most importantly, it's a connection-oriented logging framework. And so every connection gets its own unique alphanumeric identifier, which means that as an analyst, as an incident responder, suddenly I can click on a UID, a connection ID, and pivot across all of that connection's protocol activity. Now, in a world without Corelight and Zeek, from a network traffic analysis perspective, that's an immensely difficult proposition, because you're going to be trying to align timestamps between different logs in your network. Does my DNS server record timestamp match up with my NetFlow? If that DNS server timestamp is misconfigured, you're going to have a lot of hunting to do to find that. Well, what happens next? Was there some sort of mail activity? Oh, well, the IT team didn't turn on my SMTP log, so I don't have that data. Those are the kind of pain points and challenges that security analysts without this data encounter every day. And that's the beauty of Corelight and Zeek, is it's all the network data you need, all in one place, all in the right format, designed for security. Now, what about encryption? That's something we often get asked about. Great question. There is a ton of detail, security relevant, security valuable detail you can tell about encrypted traffic without breaking and inspecting it. And so this is just a sample of some of the encrypted traffic protocols that Corelight and Zeek parse. And it turns out when you richly parse the nature of an encrypted handshake and also the certificate details associated with that encrypted handshake, there's some really powerful security insights that can come out of that parsing. And again, this isn't breaking and inspecting the traffic. It's just simply analyzing the nature of the encrypted handshake and the certificate details. And you can do really powerful things like someone in the open source Zeek community figured out you could actually hash the client server kind of TLS negotiation. And so you can actually hash and track encrypted connections, which means you can start to whitelist and blacklist those connections. You can whitelist all the known good in your environment and alert on any time there's something unknown, or you can rely on community blacklists to start alerting proactively on known malicious encryption. So that's just one example of some of the powerful insights you can get, even if the traffic is encrypted. So at the end of the day, what's the value of all of this from a customer perspective? Well, back to those 3 pain points that I mentioned at the beginning of my section. From a threat detection perspective, with this incredible data, you can drive better signal to noise in your security analytics. You can start to tune your existing security analytics. You can start to build new security analytics, and you can start to customize them to your environment. Because this is a flexible, extensible data platform, you can actually start to build your own detections, which is honestly the most powerful thing I think any organization can do, because when you start to customize to your own environment, that significantly raises the bar of attack for customers, or for attackers, I should say. From an incident response perspective, we can make each member of that incident response team dramatically more productive and effective at their job by giving them all of the network data they need right at their fingertips. So they can start flying through alerts and start resolving them from a network perspective in a matter of minutes instead of hours on average, for example. And from a threat hunting perspective, what this does is it really unlocks the threat hunting ground for threat hunters to go out there and analyze network traffic at speed, at scale, across their entire environment, and start to test for hypotheses like, I wonder if there's any evidence of DNS tunneling in my environment. Well, with this data, they don't need to go rely on the IT team for DNS server logging. They've got all the DNS data they need right in one place. So Corelight's got customers spread across the globe. We've got customers across all major verticals. I think now 9 of the Fortune 50 are Corelight customers globally. So very large organizations have trusted Corelight to kind of be this anchor tenant of their network traffic analysis stack. And here's just a sampling of some of the great customer outcomes we've helped drive. So a major multinational energy company, our data allowed them to effectively tune down their false positives in their IDS system. So they already had an IDS tool in place. We came in, and with this rich data, they were able to tune down the tool effectively, which reduces the strain and stress, of course, on their incident response team and allows them to focus on higher priority things. A major international law firm actually used the data we generated and instrumented a downstream analytics tool called Rita, which is an open source network traffic analysis tool that allows you to look for evidence of beaconing and lateral movement. And so they used a subset of the logs we generated to generate a daily report for their analysts to go investigate every day, looking for that evidence. So it's a very high signal to noise ratio insight. And lastly, a major educational services organization, a global company with more than, I think, 40 or 50,000 employees, took their average incident response time down and reduced it 95%, which is just a really dramatic illustration of the power of this kind of data set. And they did that because previously they were playing that bad puzzle game. Oh, excuse my update. They were playing that bad puzzle game of trying to correlate non-security optimized network data sources. And now suddenly at their fingertips, they had everything they needed, and they were able to make lightning fast sense of it in their SIM of choice. And so it took the average incident response time down from a couple of hours down to a matter of minutes. So it was a really dramatic outcome for them to increase the productivity of those people on their team. And lastly, we're wrapping up this section here. I just want to leave this thought in viewers' minds, which is that here at Corelight, we see there's kind of fundamentally 2 ways to approach NTA. And that's, do you approach it with a data-first mentality and priority, or a detection-first priority and mentality? And the difference between those 2 things can be dramatic because, from a data-first perspective, you're making data the first-class citizen there, and you're making sure that you've instrumented pan network visibility, rich network visibility, before you start to layer on security analytics. And on the other side of the equation, if you're leading with a detection-first strategy, you're probably using a tool that's giving you, a beautifully designed pane of glass and a rich set of security analytics, and they're trying to monopolize your time in that pane of glass, and their detections means you're going to be pivoting into your SIM. You're going to have to rely on them for your detection strategy, and ultimately, philosophically, you're basically starting with opinions and then seeking the truth being the objective data reality of what's happening on your network. And that's going to lead to a lot of challenges. You lose a lot of control over your environment when you outsource, the opinions and detections of your network to vendors and allow them to control what data they expose, what objective data they expose about your networked environment. Versus a tool like Corelight, where you choose Corelight to be the anchor tenant in your network traffic analysis stack, you get to control that destiny. You own the data in format. Because it's an open source product, you can take that Zeek data and put it in any number of tools downstream. You get to own your detection strategy. You can build on top of community detections. You can build on top of third-party analytics that you stream Corelight's data to and actually instrument your own detections. And the beauty, of course, of a tool like Corelight, that's a data-first solution, is you get to aggregate all of that data in one lake, and you don't have to pivot between detection pane of glass and your SIM tool. It's just all in one place. And really, at the end of the day, the customer outcomes that get driven by these two different approaches it's the difference between deciding that you're going to proactively identify risk in your environment, and you're going to enable hunting and data science and custom analytics and detection, or you're going to outsource that to a third-party vendor and really be in a reactive mode. And your analysts are going to be reacting to the alerts generated by that stack and trying to triage and respond to those alerts without the data context to effectively do that. And so we would encourage someone looking at this space, looking at investing in NTA, to really think hard about what approach they want to take to this problem. And of course, we're biased. We believe data first offers all of those advantages that I mentioned. But if you are inclined to take that approach, Corelight is an excellent solution. So lastly, I'll just end here and we'll flip to Q&A in our last few minutes. It's really simple to set up our product. It's not a heavy lift at all. Customers often ask us when they're looking at our product, oh, how many engineers I'm going to need to put on this project? How many weeks should I set aside? The answer is one engineer and a few minutes. It's really that simple. You take our sensor, you deploy it, you configure it to export data to your security tool or data lake of choice, and you're off and running in honestly less than 15 minutes. And many of our customers have gotten it up and running in far less than that. In fact, one customer told us it took him longer to unbox our physical sensor for his physical network environment and move it to the rack and plug it in than it did to actually configure and set it up for data export. So it's a really easy lift to try to POC a Corelight sensor and understand the value of this data in your network traffic analysis stack. So with that, in our last few minutes here, I'll take a few questions. We've had a few questions already, so let's see here. Start with this question. Do you think Corelight's data can replace PCAP and/or NetFlow? It's a great question and one we often get. From a security perspective, I'll say yes, it can definitely replace NetFlow. And from a PCAP perspective, I'll answer with the somewhat less satisfying, it depends. So because we're abstracting the network traffic into these logs, you are, of course, losing some of the packet level detail there because these logs are abstractions of those packets and the activity on the wire. And so there are some circumstances where the logs generated by Corelight may not capture the level of detail you need. But what we find, what our customers find, is for the vast majority of use cases, they don't need to go to PCAP. They can just use Corelight's Zeek logs. And so again, it depends. We've had customers that have replaced entire PCAP infrastructure and just turned to Zeek logs and Corelight for that level of network insight. And then some have decided to continue to collect a limited amount of PCAP in parallel to Zeek logs. And actually, Corelight's logs can enhance your PCAP offering by allowing you to very efficiently pivot into the right packets you need because of the rich kind of connection-oriented logging, the rich time stamping that Corelight logs generated. So it allows the analysts to get to the packets they need much faster if they're running Corelight in parallel. Let's see here. We've got a question about decryption. So how does encrypted traffic work? Is it possible to decrypt? Can Corelight do that? Great question. Another common question we get. So first of all, I'll just answer directly. No, Corelight and Zeek do not decrypt data. That's not part of the capability set of the open source technology or Corelight's commercial product offerings. So we can certainly accept decrypted data if you have a tool upstream of Corelight, such as a packet broker that's handling the decryption for you and managing those certificates. But I will say that, again, there is a lot of rich detail you can get around encrypted traffic without breaking and inspecting it. And so not only is it things like blacklisting and whitelisting encrypted connections in your environment, but you also get the context around an encrypted connection, because attackers like to use encryption too. And it's almost invariably true that an attack is never 100% encrypted. And so because there's a connection-oriented logging framework here, you get that context. So let's say a DNS request is made in the clear, right, before the connection gets encrypted. Well, that gets logged and stamped with the UID of the connection, which allows you as an analyst to then pivot into the SSL log when that traffic does become encrypted. And so it gives you the context around encrypted activity that you're going to be missing otherwise. So that's another element of a powerful encrypted-based insight you can get without breaking and inspecting with Corelight. We've got 1 or 2 minutes left here, so we'll probably have time for 2 more questions here. Let's see here. Do I need a packet broker to use Corelight? Can I use a TAP? Good question. So we recommend using a packet broker if you're dealing with a physical network environment, just because its scale, reliability of traffic mirroring and load balancing and all of those tricky details typically necessitate a purpose-built solution like a packet broker to handle that. You can certainly use an optical tap or a span port to stream packets to Corelight for analysis. You don't need a packet broker necessarily, but we do recommend that for complex network environments, really at any scale. Very quickly, the reliability of a tap it can become problematic at scale, and so typically a packet broker who can do all of that, complex traffic management and routing is recommended. Let's see. I think we have time for 1 more question here. We've got a question here. Other products use Zeek. What makes Corelight different? Great question. I mentioned this earlier. We were founded by the inventor of Zeek and the key open source contributors. And not only does that give us a human knowledge advantage, but that translates directly into a product advantage. And for all of the open source challenges that the open source community faces around scale and usability of Zeek, our competitors face as well. And so, that human resource advantage we have has allowed us to do things like scale a physical network appliance to Zeek to 25 gigabits per second, when the next best kind of open source or competitive attempt at that usually taps out around 3 or 4 or 5 gigabits per second. So, a dramatic increase in performance is just one example of some of the product level customer outcome benefits that Corelight enjoys because of that, human knowledge advantage we have as being founded by the inventors. Well, we're at the top of the hour here. So with that, I'm going to close it. I'm sorry we didn't get to all the questions. We'll follow up with you afterwards directly via email. Thank you so much for attending. Jon Oltsik, thank you for sharing with us your great research and insight into this space. I really appreciate it, and I certainly learned a lot. Thank you so much.
My pleasure.
Have a great day. And with that, we'll conclude today's webcast.